Hello again, it is Mr. Ensminger here with another video on for loops. This time we're going to be looking at for loops and how we can interact with strings. Remember that strings are our alphanumeric data. It is words, characters, sentences, things of that nature. So I'm going to start off by making a word variable. And I'll just use something simple like computer. A word equals quote computer, which no different than a numeric variable. Total equals 0, count equals 5, whatever. I mean, a string variable is just equal to a word. It has to be in quotes because strings are in quotes. So now, we haven't done a ton with strings. The numbers are a little bit easier to work with early on because all of you know math. Strings are concepts somewhat unique to computers. And so when we do this, these applications, we're going to do things like, well, let's print the letters. Let's see how many vowels are in the word, or is there a letter A? You'll see this come up in so many different places. Hangman, Wheel of Fortune, Scrabble, Words with Friends, Boggle, any kind of game where you involve guess a letter, pick a letter, figure out the letter. Any of those games involve manipulation of strings. And so it's not like numbers are more important, it's just that they're easier to work with. But as we get more experience, we'll be working more and more with these strings, with words. So let's do it. We're going to do a for loop. And you're like, well, how do we do a range of a word? Let me show you. What makes up a string? What makes up a word? What are the individual parts of a word? Letters. So what I'm going to say is for letter. Now, does it have to be letter? No, that's a variable name I made up. It could still be n. It could be x. But as we've seen, you want your variables to be descriptive. And so what are the individual parts of a list of numbers? It'd be a number. What are the individual parts of a word? Letters. So for letter in range, no. In the word. For letter in word. Singular, plural. Individual, list. Let me print the letters now. If I print the letters of the word, what do you think it's going to give me? Well, there are all my letters in the word. Computer. It took each letter and printed out one by one. If I wanted to do something like print them left to right, and not together, because if you print them left to right together, it print the word. Duh. So let me do it again. Let me just take this and copy and paste. Put this back over there. Let me put asterisks in between each letter. End equals quote, asterisk, quote. And of course, we want to print by itself at the end, as we saw in the last video. You want to print down. Let me try that out. Check this out. Computer with stars. Hooray. Now, when I said it was in between each letter, the little hiccup would be the R will still have a letter or an asterisk after it. With what we have right now, this is what it is. Not really going to mess with that, but there we go. What else can we do? No, once again, let me just grab this, steal it. What if I want to look through a word for a particular letter? Is the letter in the word? That's an if statement. If letter, make sure you use double equals, quote, you want to look for letter E? Print this word contains the letter E. Else, print this word does not contain the letter E. And, because we already, spoiler alert, computer does contain the letter E, let's change it up a little bit. We will say something like word 2 equals input. Please enter a word. And then instead of word, we'll say word 2. So that way there's at least a little air of mystery to our program. Please enter a word. How about aardvark? Does aardvark contain the letter E? No. But look at what happens here. The word does not contain the letter E, and it says it a whole bunch of times. In fact, it says it 8 times. Oh, okay. Let's go back and do one that does contain the letter E. Computer contains the letter E. Look at what happens here. Uh-oh. The word does not. It does and does not. It's because we're doing if and we're doing else. We're saying each letter, does each letter left to right, is it the letter E? And so C, is C the letter E? Nope. Is O the letter E? Nope. So C-O-M-P-U-T-E, there's the E. So we want to do this, but we don't quite want to do it this way. We want to change our code around a little bit because we don't want to say yes or no every single time. So instead, as some of you have determined, you can make variables true, false, Boolean variables. Found E equals, I'm going to start it as false because I want to assume I have not found a letter E. What we're doing is something we call in math proof by counterexample. We say assume it's not until proven otherwise. Meaning, look through, oh, I found the letter E. So instead, found E equals true. But I don't do an else, because that's the trick. Don't do if else. We just want to say assume it's false. Look through C, nope, O, nope, P-U-T-E, E is true. So I found an E. And now after I'm done, I can say if found E double equals true, print the word contains a letter E. Capital. Now you can say else. Else. Print the word does not contain a letter E. Now let's try it again. So we don't want to print it out every time. We don't want to do the output in the loop. We want to do it after it's done. So now let's do aardvark. Just says it one time. The word does not contain letter E. Let's do it again. Let's do it again with a word that does contain an E. Let's do computer. It does contain letter E. What if my word contains multiple letter E's? Is it going to tell me dozens of times? No. If I try engine, which contains 2 E's, it only tells me one time. So these are just the little things you want to think about when you're doing programming is you know these commands, you've been introduced to them, you know if and else, you know while loops, now you know for loops, you know random numbers. But just knowing those things is not good enough. It's just like if you memorize the encyclopedia, that doesn't make you a good writer. You need to know how to put sentences together, and then sentences make the paragraph. Coding is the same thing. You need to take this, put it together into a logical flow, and discover, oh, there's my program. Let's do one more. Let me count the number of vowels and consonants. Vowels, A, E, I, O, U. I'm not going to do sometimes Y, just O, A, E, I, O, U. Consonants are just all the others. B, C, D, on. So, once again, I'll use 4-letter in or to. And then how do I do an if statement with vowels? Well, because I'm counting vowels, I'm going to need a counter. So vowels equals 0. If letter double equals A. But wait, there's 4 others. Here's the mistake a lot of people make. Don't just do this. With and or, you have to spell out the entire comparison. You can't just say or E. You have to say or letter equals E. Or letter equals I. I know it's tedious, but it's just the way it is. Or letter double equals O. Or letter double equals U. Vowels equals vowels plus 1. What if it's not a vowel? Else, well, without spelling the whole thing, I'm just going to put cons for consonants. Else, cons equals cons plus 1. At the end, after loop's done, print the word contains, comma, vowels, print, and consonants. Let's check it out. Please enter a word. Computer. The word contains 3 vowels, 5 consonants. Does it? O, U, E. Those are my 3 vowels. It's an 8-letter word. So there's 5 consonants. Notice when I did my if statement, I counted the vowels. I didn't count the consonants because I'm not an idiot. I'm not going to count 21 different parts of this. Do this and use else as the complement of it. If you don't have a vowel, you have a consonant. Of course, this would fail if you have something like an apostrophe or a space, but we're only doing words. We're not saying enter a sentence. So we're sort of, we're just playing it safe. But there's a couple of different applications you can do, as you see here, with for loops, not with numbers, but with strings. Thanks for watching.